in this video I wanted to do just a short brief reminder or snapshot into linear inequalities using one variable. So here's just some examples and some reminder tips to try and help you with these types of problems. So first of all, let's look at solving. So when we are solving linear inequalities, you are going to solve it the same way you would a straight linear equation. The only difference is you need to pay attention to your inequality sign. The biggest rule we have is that if you multiply or divide with a negative value, then you must flip the direction of your inequality sign. So let's take a look at a couple examples so that you can see how some of this works. So in this first example, the first thing that I always do is I like to try and circle my inequality so that I see or remember what's going on with it. So here on this left hand side, I have to distribute into my parentheses first before I can do anything else. So here distributing that 3 means that this is going to become a 3x. 3 times negative 2 is a negative 6, and then minus 2. Put in my inequality sign because I haven't done anything yet, and then I've got 6x minus 5. Over here I can combine my two like terms, so negative 6 minus 2 is going to give me 3x minus 8. Again, put my sign as is because I haven't done anything with it yet, and then I have 6x minus 5. Now, I would take my 3x here and move it. Because it's positive, to move it says I have to subtract. And then I would take my 5 and move it. So I would take this 5 here. And again, I would move it the other direction. And because it's negative, I move it by adding. So I have 6x minus 3x is going to give me a 3x. And then I have negative 8 plus 5 is going to give me a negative 3. And then again, input my sign because I haven't done anything with it. Now the last thing I need to do is get x by itself. And in this case, I need to divide everything by 3. Since my 3 is positive, my sign stays the same. And I end up with negative 1 is less than x. So this here is your inequality result. Now, sometimes you have to graph your result on a number line and then write in interval notation. So in order to do that, I have a number line here. And when you're drawing your number lines, you need to remember the left-hand side is the negative, the right-hand side is the positive. Somewhere in the middle would be your 0, and then at this point we have a negative 1. Now if we look at this inequality, we're saying that x is going to be all values that are larger than negative 1 but don't include negative 1. So that means we're going to be putting a parenthesis around negative 1 because it's not included, and we simply shade off to the larger side. Now, once you create your graph, your interval will match your graph. So in this point, I start with a parenthesis. I input my negative 1, saying that negative 1 is not included, and I'm going to travel all the way up through positive infinity. And then my infinities are always surrounded by parentheses. Now, when you're doing yours, obviously you don't have to designate it as being positive. You could just draw it as infinity. But I like to designate it for myself just so that I keep things straight. Okay? But there you go. That's what you needed to do. So let's take a look at another example. Alright, so down here I have this fraction. So there's a couple ways that you could approach this problem. First, we could get rid of the fraction right away, or we could combine our numbers and then get rid of the fraction second. Since the fraction is attached to the variable, what I would do is I would go ahead and take this 11 and move it across my equal sign there. Because the 11 is positive, to move it says I have to subtract. And so that's going to leave me with negative 3/2 r. Again, if I pay attention to my inequality, I need to draw it as is, and then I have negative 4 minus 11 is a negative 15. I then want to multiply this whole thing by 2, which is going to give me negative 3r is greater than or equal to negative 30. And then the last thing I have to do is divide by negative 3. Now, because I'm dividing by a negative, so this part right here says I need to flip my sign. So this means I'm going to have r. Flipping my sign says now it goes the other direction. And then negative 30 divided by negative 3 is a positive 10. And this would be your inequality. Now again, I have to draw its number line. So I've got negative infinity to positive infinity. Put my 0 somewhere in the middle. And here I'm starting with 10, so I'm going to drop in my 10. And I'm saying that r is going to be every number less than or equal to. The equal to part says I need to drop in a bracket. And then I'm drawing everything less than. Okay. So again, to make my interval match my graph, I'm going to start with a parenthesis because I'm starting from negative infinity. I'm traveling up through 10, but 10 is included. Okay. Now we can also have an idea called compound inequalities. Compound inequalities are inequalities that are joined by the word and or. It essentially says we're talking about more than one inequality being compared or used in conjunction with another. So in order to solve these, you have to pay very close attention. First of all, we have what's called a conjunction. Now, a conjunction usually has the word and, or is written where you can see that the variable is in between two outer terms. Okay? Now, the other one that we have is called disjunction. Disjunction is or. So when we're talking about disjunction, we are talking about the word or. Okay? So if we look at these examples, we can see the first one says that I'm going to use 2z minus 1 is less than or equal to 5, or 3z minus 5 is greater than 10. So when we're talking about an or, we are talking about a graph that is going to look like wings. Okay, now obviously you can have any means of parenthesis or bracket, but it looks like wings. I like to think of it as like the oars of a boat. So if you think about a rowboat, your oars stick out to the side, and then you sit in the middle. Okay, so here we've got an or. What that means is we have to solve both of these separately, but we solve them together. So when we're looking at this first one, I need to take this one and I need to move it to the other side. Because it's negative, to move it says I have to add. So this is going to give me that 2z. I have to pay attention to the direction of my sign is less than or equal to, and then 5 plus 1 is 6. Now I have to divide everything by 2. Notice the 2 is positive, so my sign stays the same. And I'm left with z is less than or equal to 3. Now I need to do the same type of thing on the other side. So first you need to pay attention here to your sign. And then I'm going to take this 5 and I'm going to move it. Again, because it's being subtracted, to move it says I have to add. So this gives me 3z is greater than 15. I need to divide everything by 3. Because my 3 is positive, my sign stays the same. So z is greater than 5. So again, we need to write or draw our graph and write our interval. So we're going to go ahead and put our graph here. So I've got the left is negative infinity, the right is positive infinity, somewhere on it is 0, and then I'm dealing with 3 and 5. So here's 3 and here's 5. So I want all values less than or equal to 3. So I'm going to put a bracket around 3, but it's got to face the negative infinity side. And then my other part says I want to have be greater than 5. So I'm going to put a bracket or a parenthesis around 5 because it's not included, and I'm going to shade off towards the positive infinity side. Now to make your interval match your graph, we're going to start at negative infinity, we're going to travel up to 3, and we're going to stop. We are then going to union to the next part. So I like to think of it as, say, a road trip. So we started from our house, we drove to the first store, and we stopped. Now we got out of our car and had to get back in our car so that we can drive off to the second store before returning home. Okay. So notice my graph and my interval look the same. I've got this blank space here in the middle, which is represented by this U, and then I've got each individual interval represented together. Okay. Now let's take a look at an AND. So in this one, notice I have two numbers on the outer side and my variable is in the middle. So the rule here is whatever you do to one, you have to do to the outer two. So the first thing I would do is I would take this 2 and I would move it. So I have to move it this direction and I have to move it in that direction. And because it's positive, I have to subtract from both sides. So -6 minus 2 gives you a -8. I again need to look at my inequalities, and so I have less than or equal to a -3m is less than or equal to, and 7 minus 2 is 5. And now I need to divide everything by the -3, and because this is negative, I have to flip my signs. So here this is going to be 8 over 3, flip my sign, is greater than or equal to my m, flip my sign, -5 over 3. So again, I need to draw my graph. So we start with the negative and we go through to the positive, put your 0 somewhere in the middle, and then I have a positive 8/3 and I have a -5/3. My inequalities are equal to, and my variable shows up between, so I'm going to use brackets, and my brackets are going to face each other, and I'm going to shade everything here in the middle. Now again, to write the interval, you make it look just like your graph. So I'm going to put a bracket. I'm starting at -5/3. I'm traveling up to 8/3, and I put a bracket. Alright, so that is a quick refresher on what it means to solve linear inequalities. So if you have any questions, please let me know. Otherwise, enjoy your math, have fun, and I'll see you next time.